Hello students, next topic is atoms. In this the size of the atom is on the order of 10 to the power of minus 10 meters, 1 angstroms. Nucleus is in the order of 10 to the power of minus 15 meters. And this atom was structure of the atom. Structure of the atom was studied by the J.J. Thomson plum pudding model, where the electron positive charges, negative charges existing together. Electron was discovered by the J.J. Thomson. He thought that electrons and positons, means atom is electrically neutral. He thought that plus and minus charges inside the atom are existing side by side, like a plum pudding model or called as a watermelon seeds model. Rutherford did the experiments. Actually, his students Giger and Ramsden did the experiments of alpha scattering experiment. Is a famous experiment because of which he discovered the nucleus, and most of the mass of the nucleus or atom is inside the nucleus. That is, nucleus means central portion, and nucleus has a positive charge and electrons are revolving around the nucleus. But according to Rutherford, what he assumed is that electrons revolving around the nucleus means they are in the circular path, they have the centripetal acceleration. Accelerated charges accelerated charges produce electromagnetic waves. Electromagnetic waves produce means they lose the energy. That is called as a classical electrodynamics. Moving of the charges produce electromagnetic fields is related to the classical. Classical means we are seeing the macroscopic level. Microscopic level is related to the quantum. So we cannot see the electron. Just they assumed all these structure of the atoms, and later studied by Bohr and Balmer and other scientists to study the structure of the atoms, how the electrons are moving inside the atom around the nucleus. But Rutherford gave the first structure of the atom, that inside the center portion is a positive charge having the nucleus. He called it as a nucleus, and electrons are revolving around that nucleus, and the accelerated electron produce the radiations. Whenever the radiations produce, it loses energy. When it loses energy, it cannot remain in the orbit, and it has to fall into the nucleus, and electron will die inside the nucleus. According to this model, there is no atom existing. Atom is there means we are all materials. All metal, even this plastic, this material, our body, clothes, everything is made of the atoms basically. That means the atom should not exist if the electron is dying into the nucleus or falling into the nucleus. Structure will not be there, but structure is stable, means this Rutherford atom models failed. And how they got this idea of the nucleus and size of the nucleus calculated is by the alpha scattering experiment. Alpha particles have the positive charge, and these positive charges are made to strike the gold plate, very thin gold plate they have taken. The thin gold, very thin gold plates. Why gold is preferred? Because it is malleable and you can beat with the help of the wooden hammer, putting the plate in between the papers. They keep on hitting it until the thickness becomes very thin. Very thin means if you are hitting this directly, you know that you are hitting the atom itself. The thickness of the foil is a T, and alpha particle have the positive charge hitting this, and the gold nucleus, if it is hitting, it is repelled backward directions. The distance, perpendicular distance between the direction of the path of these particles and the center of the nucleus, that is called as the impact parameter, taken as the symbol B. B is called as the impact parameters. And these particles going here, they get repelled by this positive charge of the nucleus and deviate in the other direction. If they are exactly passing through the center line, that is called as head-on collisions. B equal to impact parameter B equal to 0. You can compare this with the carom boards. When the carom boards, if you are hitting exactly midpoint, they go in the straight line path. That is a head-on collisions, straight line motion will get, but one-dimensional collision. If your striker is not hitting at the center, it is hitting at the sides, they deviate to the sideways. Coin and striker go to the sideways, that is a two-dimensional collision. Here in this case, the positive charges hitting with the nucleus is like elastic collision, but nucleus is very heavy, do not get displaced, only alpha particles get displaced. Then they are going center one, they will be repelled backwards. Exactly center if they are going means they go backward direction. The B equal to 0, when B equal to 0, theta is equals to 180 degrees, means the alpha particles retrace the path, go backwards. The minimum distance of approach, at this minimum distance of approach, it won't touch the nucleus because the plus repulsion will be there, and it won't touch the nucleus. In these cases, the minimum distance R taken as R minimum. Based on this, they calculated the size of the nucleus. If the B value increases, the theta value decreases. If B increases means theta decreases. If the particles are coming very close to the nucleus, more repulsion will be there. Then the more repulsion is there, they deviate more backward. They deviate more means theta is more. And Rutherford and his students Giger and Ramsden observed that very few particles are deviated by 90 degrees more than this. Most of them are just located in the center portion. Exact midpoint, there is no alpha particle detected. How do you get this alpha detected? Means they have taken one zinc sulfide screen. It's called as fluorescent screen. Whenever the charged particles strike it, you will get the glow on the surfaces. The glow is called as a scintillations. It's called as a scattering angle. And they observe the most of the deviations very around the center only, but that depends on the, of course, beam of the alpha particles. Not one particle, many particles will be coming. Some particles go in the middle, some particles go in different directions, and different deviations will take place. And this is a 90-degree deviation, and when you come very close to the nucleus, they deviated complete backwards. Exactly theta equal to 0 if you have taken, that means that this theta equal to 180 degrees, means going forward and backward, retracing the path. Theta is 180, means B equal to 0, impact parameter is 0. And other formulas I gave in the notes, don't go for all the formulas. This number of particles scattered, accounting on the scintillations on this zinc surface screen is number of particles scattered related to the thickness of the gold foil. N is proportional to T. More thickness, more reflections, but the bigger, more nuclei will be there. N by T equal to constant. This one problem you need to go through. Next is the minimum distance relationship is the kinetic energy of the particle becomes equal to 0 at this instant when it is coming closest distance, but again retracing backwards. At this point it has only potential energy. That means loss of kinetic energy converted into potential energy. Kinetic energy formula is half mv square. Mass of alpha particle is taken as 4 particles, 2 protons and 2 neutrons. Mass number is 4 we take actually for this. And half mv square, this is for alpha particles, is equals to potential energy is nothing but equal to q1 q2 by 4 to r formula we have, and charge of this alpha particle is q equal to e, q1 is e, and gold nucleus q2 equal to z. Z is the number of protons in the nucleus. That for rm they have taken gold, rm z is equal to 79. That they don't ask of course, but just have an idea. So this becomes equal to q1. Any nucleus given now, you take this potential energy form is nothing but equal to modulus we require minus z square by 4 into r minimum. This r is r minimum we have to take, minimum. So velocity in minimum distance, they will ask the relationship v square is inverse proportional to r minimum is proportional to v square. If the kinetic energy is doubled, this kinetic energy denominator, kinetic energy doubled means r becomes equal to half, or v is doubled. V is doubled is different case. When v is doubled, it will becomes equal to 1/4. The distance becomes equal to 1/4. Kinetic energy given means r minimum is inversely related to kinetic energy. Next, this Rutherford atom model failed because the electron falling into the nucleus by losing the energy, but then Bohr gave the theory for the structure of the atom. According to the Bohr atom model, and it is applicable, he has given some postulates, some rules to get the relations for the radius and energy and velocity of the electron in the orbits around the nucleus. And this Bohr theory is applicable only for the atoms with one electron only. There can be any number of protons, but it must be required is only one electron. And the postulates are given by the Bohr. His first postulate is that related to the stationary orbits. Electron revolving around the nucleus, they do not emit the radiations in the specific orbits called as the stationary orbits. If they jump to that, if they are not in that stationary orbit, they may produce the radiations, and they always try to remain in the stationary orbit. If you are taken to the other orbit, again they go back to the stationary orbits. Electrons revolving the stationary orbit do not emit the radiations. Next, second postulate is more important ones. Angular momentum of the electron in that orbit. Angular momentum is actually mvr sin theta. Theta is 90 degrees between the velocity and radius for circular motion. Therefore, mvr sin theta is equals to 1 only. Take mvr equal to nh by 2 pi. This is the second law. According to first law, according to the first law, stationary orbits are circular orbits he mentioned. So this is circular orbits. Electrons revolve in the circular path around the nucleus. The closed path is called as the orbit. And angular second postulate is the angular momentum equal to nh by 2 pi. N is called as a orbit number. Later that is called as the principal quantum number. H is a Planck's constant. This h by 2 pi also sometimes mentioned as h bar. H bar is nothing but equal means h by 2 pi. Next, third postulate. When the electron is jumping from one energy level to other energy level, the difference in energy level produces the radiation. It emits the radiation now when it is jumping from one energy level to other energy level, because it accelerates. Accelerated charges produce electromagnetic waves. Now it is accelerated, producing the radiation of the frequency f and wavelength equal to lambda, energy equal to hc by lambda, hf we can take. So first postulate says that electrons revolving in the orbit in the particular around the nucleus in the particular paths, closed paths. So that it staged, for example, n equal to 1. It is called the ground state. Electron always try to be in the ground state. But if you observe the energy by heating methods, by heating it and by means of the photoelectric effect with less energy, The photons fall on this electron and electron absorb the energy. Then if the energy is not sufficient to take out of the material, then it will be jumping from lower energy level to higher energy level. That means its radius increases. Whenever the radius increases, go away from the attraction of the nucleus, it should have the more energy. That means outer orbits have the more energy than inner orbits. And it cannot go to any orbit you want. It has a particular orbit's rotation only. That means here every orbit is quantized. Specific values only we can take, whatever want you cannot take. Angular momentum is also quantized. Specific quantum number is only possible 1 times h by 2 pi, 2 pi times h by 2 pi. You cannot take 1.5, 2.5. Fractional values are not permitted. Similarly, energy is also quantized. And that means energy is proportional to frequency. If it does not, fractional values you cannot get the other values. So whenever the electron is jumping from lower to higher, it has to absorb the energy. Unstable in higher orbits, again jump back to the lower orbits. The higher orbit lifespan, that means excited atom, it's called as the excited atom. Lifespan is nothing but equal to 10 to the power of minus 8 seconds. Again, electron jump back to the ground state within this time. This 10 to the power of minus 8 seconds is called as a shake. SHAKE. It is the time unit for the small time 10 to the power of minus 8 seconds. The electron jump to the lower energy level. An electron may jump to the next energy level and next energy to the ground state. Always try to come back to the ground state. During the process, maybe the radiation, the difference in energy level equal to hc by lambda. And by applying this centripetal force equal to electrostatic force of attraction. Why the electron is revolving circular path, for circular motion path compulsory requires centripetal force. The electrostatic force of attraction with the electron, negative charge and positive nucleus provide the necessary centripetal force. So electrostatic force equal to centripetal force. A centripetal force is mv square by r. V is the speed of the electron, r is the radius of the orbit, z is the atomic number, m is the mass of the electron, e is the charge of the electron. This z square by 4 into r square. R is the radius. You can calculate the corresponding expressions for the radius, energy and velocity of the electron in the particular orbit. And this graph is also important for the Rutherford scattering experiments, as theta versus the number of particles is scattered. Check up with that graph that should not touch x-axis or y-axis. Next is radius of the electron in the nth orbit. This is related to the Bohr orbit postulates, but Bohr orbit postulates are applicable only for the atoms with the single electron in the orbit. They can have any number of protons. For hydrogen atom, if you have taken, z is equals to 1. Ground state, if you have taken, means n equal to 1 and n equal to 2. This angular momentum nh by 2 pi, n is equals to 1, 2, 3, 4, etc. We can take the numbers. N equal to infinity means electron is far away from the atom, that is called as a ionization. N equal to 1 is called as a ground state. N equal to 2 called as the first excited state. N equal to 3 is called as the second excited state. These are all excited states, but the electron try to be always in the ground state, that is n equal to 1. For hydrogen atom, it has only one electron and one proton in the nucleus. Isotopes can have the more than one proton. Deuterium has a one more neutron in the nucleus, but the neutrons do not give the charge for us. What you are discussing is based on the number of protons only, means atomic number, not mass numbers. Neutrons provide only the weight and some physical properties can change, but that is the one which provides the nature of the elements. Mainly in the periodic table, elements are arranged based on the Z number, means number of protons only. Atomic number important for us. For the chemical reactions also, that is important. Next is for hydrogen atom, that is equals to 1. For helium atom, helium has 2 neutrons, 2 protons. For a neutral atom, a number of protons is equals to number of electrons. Number of protons is equals to number of electrons always for neutral atom. So this helium has 2 protons, 2 neutrons, means automatically it has 2 electrons. But 2 electrons we cannot apply Bohr's postulate, we have to apply only 1 electron is there, means 1 electron is removed. 1 electron means singly ionized helium. Lithium has 3 protons, 3 electrons, 2 electrons removed, means doubly ionized. Similarly, beryllium, triply ionized we have to take. The values you have to take, you have to remember for these 4 elements. Next, by applying this relationship of centripetal force and electrostatic force, you can get the expression for the radius, velocities and energy of the electron in the nth orbit. Radius of nth orbit expression is h epsilon naught by pi m into e square, n square by z. You have to remember the relation in terms of these symbols and also in terms of the numerical values. That is equal to 0.529 into n square by z. Mostly they will ask based on this relationship. 0.529 is a constant you will get by putting the values for all these constant values into n square by z. For ground state, n equal to 1. Z for hydrogen, z is also equal to 1. If you substitute these two, you will get for hydrogen, the ground state, the radius of the orbit is equals to 0.529. This is called the Bohr's orbit. The units are in angstroms I mentioned. This radius of the orbit is proportional to n square, inversely proportional to z. That means if in the periodic table z value increases from left to right side. As the z value increases, atomic number increases, radius decreases. Uranium, like that, if you are taking heavy elements, that is very high. When very high means the radius is very, very less, electron revolves so very close to the nucleus. Attraction is also very large. When attraction z is very large means more number of protons are there, means more attraction, radius will be less. And as n number increases, radius also increases, but not in the linear fashion. R is proportional to n square. N equal to 1 ground state, n equal to 2 first exist state, n equal to 3 second exist state. So the ratio of the radii they will ask you, that is equals to n square, means 1 square, next is 2 square, 3 square, 4 square, 1, 4, 9, 16, like that you will get the relations. The ratio they will ask you, check up that. Next, velocity of the electron in the nth orbit. Velocity of the electron in the orbit is square by 2 epsilon into h. H is the Planck's constant. Epsilon naught is the permittivity of the vacuum. E is the charge of the electron into z by n square. By putting these values, if this is equivalent to c by 137 to z by n, this relation is important. This symbol is not required for the important for this velocity. This relation is important. C by 137 z by n. C is nothing but speed of light in vacuum, which is 3 × 10⁻⁸ meter per second. And this velocity of the electron, by substituting this C and 137 is 2.2 × 10⁶ into z by n meter per second. For hydrogen atom, z is equals to 1, n is equals to 1 for the ground state and 2 for the first exit state, and so on. If n increases, velocity decreases, means outermost orbits have the less speed than the inner orbits. Inner orbits have the inside very close to the nucleus, means velocity is more. As the electron is taken away from the nucleus, the speed goes on decreasing the orbit. Next, energy of the electron in the orbit. Because of the attraction by the nucleus, it has the potential energy, and because of the motion velocity, it has the kinetic energy. So total energy of the electron in the orbit is nothing but equal to kinetic energy plus potential energy to take. Potential energy, attraction is there means, and minus you have to take. And total energy, by substitute calculation, what you can get is total energy is equals to, this is very, very important relationship, minus of kinetic energy is equals to potential energy by 2. This is a numerical relationship. Total energy is always negative. Negative indicates attraction. If energy, total energy is positive or 0, it is not attracted to the nucleus, electron escape from the nucleus and go to the infinity. That is called as ionizations. And minus of kinetic energy. Kinetic energy is always positive, but numerical equivalent. Total energy is numerically equal to kinetic energy, but negative sign. Minus indicates attraction for the total energy. Similarly, potential energy. Total energy is half of the potential energy numerically. So potential energy is also negative. Potential energy is due to the attraction only present, that is because negative. Potential energy is negative. Kinetic energy is always positive. Total energy is negative. Potential energy is negative. If total kinetic energy is half mv square, even the velocity is negative taken also, v square makes it positive. Kinetic energy is always positive, remember that. But total energy can be positive, 0 also, but in this case it should be negative. Negative only it attracts and electron in the orbit. If electron energy is 0 or positive means the atom will not be there with the electron. It means only nucleus can exist, electron will not be bound to the nucleus. Potential energy also should be negative for the electron to bound to the nucleus. Next, total energy formula. This you have to remember this formula in terms of the symbols also, in terms of the radius and in terms of the z and n. If you take the in terms of the radius, minus z square by 8 pi epsilon into r, minus is required for the total energy as well as potential energy. Next, this is also equal to ma to the power of 4. This formula you have to remember, ma to the power of 4, 8 pi epsilon into h square into z square by n square. And this these constant values you substitute, you will get the energy in the nth orbit equal to minus 13.6 into z square by n square in terms of electron volt. If n increases, what happens to the energy? The energy as n increases, n is coming in the denominator, the energy should decrease, but because the minus sign, the energy increases. This point is important. As the orbit number increases, the velocity decreases. Outer orbits have less speed, but total energy, if you check up, the total energy increases only because of the negative sign. Outer orbits have the more energy. If they don't have energy, they will be falling back to the nucleus. To escape from the attraction, they must have the more energy only. Next point is Rydberg constant. It is a constant. Rydberg is the name of scientist. For any atom, Rydberg constant value is R into Z square. This R or RH, simply written as R also. Z square is for any atom. Z is the atomic number. For the hydrogen atom, if you take Z equal to 1, the Rydberg constant, this symbol you have to remember, value also you have to remember. Me to the power of 4 by 8 epsilon into CH cube, which is nothing but equal to, substitute the values, you will get 1.097 to the power of 7 per meter. Units also important for Rydberg constant. Next is wave number. What is wave number is, number of waves in 1 meter length is called as wave number. When electron is jumping from higher energy level to lower energy level in the orbit, it emits the radiations. The radiations are nothing but electromagnetic waves. These electromagnetic waves produce like this. These are the wave, one wave. If the frequency is high, more energy difference means more frequency equal to HF. The frequency is high means wavelength is less. So in 1 meter length, L equal to 1 meter length, how many wavelengths are fitting? This is 1 lambda. If the wavelength is larger, in 1 meter length you will get only few waves. If the wavelength is less, the frequency is high, in the 1 meter length you will get more waves. That is, number of waves in 1 meter length is called as wave number. That indirectly gives us the idea of wavelength. Less wavelength, more wave number. The wave number symbol is nu bar. It is not a frequency, please. A nu bar is not a frequency. It is just a symbol for the wave number is reciprocal of the wavelength. So units for the wave number is per meter again. Just similar to the Rydberg constant. This is nothing but equal to R into Z square into 1 by N1 square minus N2 square. The energy difference, when an electron is jumping from one energy level to other energy level, the energy difference is nothing but equal to energy formula what you have got is equal to minus 13.6 into Z square by N square. So when you are taking this E2 minus E1, E2 is corresponding to higher energy level N2 and inner energy level is N1. The difference becomes substitution of these values. You will get the expression equal to R into Z square, that I gave 13.6 in terms of the symbols if you have taken for the energies, R into Z square into 1 by N1 square minus 1 by N2 square. N1 is the inner orbit ones, N2 is the higher orbit ones. So electron jumping from N2 to N1, the energy radiated have the wavelength is equals to lambda. And if we can find out the frequency from this relationship, C equal to F lambda, C is speed of light in vacuum. So energy equal to Hc by lambda is also HF relation. We can take the expression for energy and also for the frequency from this. And for hydrogen atom, if you have taken Z is equals to 1, then wave number equal to 1 by lambda equal to R into 1 by N1 square minus N2 square. This is mostly asked problem. And some cases, very rarely, this formula also used. If other than hydrogen gear means wherever R is replaced with RZ square. And energy relationship from the basic relation for energy in terms of the symbols m to the power of 4 and etc. symbols if you substitute and also R, this Rydberg constant substitution if you have taken, you will get the expression for the basic relation of energy in the nth orbit term. You will get as minus R change Z by N square. This one only symbol they may ask, rarely of course asked, only in terms of the symbols. Not of much important, but just to have an idea. Next is electron jumping from higher energy level to lower energy level emit the radiations. So what is the frequency of radiation emitted equal to HF formula. So electrons are jumping from higher energy level lower energy level accelerates as the electromagnetic waves. E equal to HF energy is emitted from this. E equal to HF or Hc by lambda waves. So depending on the electron jumping from which energy level to ground state or which energy level to which energy level, the frequency will be different. These are studied for the discharge tubes. All these studies starting from the Bohr atom model also. The studies was done the discharge tube. Discharge tube is nothing but a tube with high voltage between the two electrodes and partial vacuum is created in the tube. That tube has a very low number of the air molecules and one terminal of the one electrode is given the positive voltage and another electrode is given the negative voltage. This is called as a cathode, positive terminal is called as a anode and cathode. High voltage is applied between these two, then electrons will jump from cathode to anode. On the path they collide with the air molecules and exit the atoms. Means excitation means what? Already atoms having the electrons, the fast moving electron from the cathode hits it. Whenever the electron are hit by that other electron, then it jumps from lower energy level to higher energy level, unstable again, it comes back. When jump backwards, get the radiations. So from this discharge tube, it's called discharge tube because a partial vacuum tube and electrons are discharged, are sent out from one terminal to other terminal, from electrode to other electrode. During that process, light is coming out. The light radiation coming out was studied by the different scientists at the different voltages, different pressures, okay, and observe the light wavelengths, and that light is passed through the prism and observe the spectra. The spectra wavelengths corresponding to this, when light is passed, composite light is passed through this prism, you will get the different wavelengths observed. But this is not may be visible, may not be visible. That was studied for the different scientists for the different energy levels. And the first one studied is by first one studies was Bohr series actually, and he gave the relationship first, which is in the visible region. Remaining studies were done which are not in the visible region later. Bohr did the first analysis theoretically, and that is in the visible region. Remaining all are not in visible regions. Lyman series. Lyman is the name of scientist, and all these are name of scientists who are discussed in the series names. And Lyman series corresponding to the electron jumping from higher energy level to the ground state. Ground state means n equal to 1. In this expression of wave number, wavelengths we can find out 1 by lambda equal to R into 1 by N1 square minus N2 square. So if the electron is jumping from higher energy level to ground state, If you take these energy level diagrams, you are taking the ground state onwards. This is not the correct diagram actually. What happens is energy is inversely proportional to n square with a negative sign. As n is increasing, doubled. N is doubled means 1/4 becomes equal to energy. If n equal to 1 ground state and n equal to 2 here and n equal to 3, this gap will be going on decreasing. This is only diagrammatic representation. N equal to 1, 2, n equal to 3, n equal to 4. The gap goes on decreasing between the energy levels. At the infinite distance means long distance from the nucleus. The energy is this electron is having enough energy to escape from the nucleus, attraction from the nucleus. This is called as a continuum. At this continuum, the electron is away from the nucleus means the atom is said to be ionized. Electron is not bound to the nucleus. There is no difference in the energy levels. At long distances, the difference is almost 0. That point is called as a continuum or continuous lines. No gap between the lines. Actually, gap between the lines goes on decreasing place. That point you have to remember in the diagrams. Next, but for clarity purpose, we are drawing here for the equal or more gap I kept. Ground state n equal to 1, first exit state is n equal to 2, means electron try to be always in the ground state. When it absorbs the energy, it jump to the next energy level. Next energy level is called as a first exit state. First exit state is corresponding to n equal to 2, and second exit state is corresponding to n equal to 3, and so on we have to take. And the outer orbit is unstable, again jumps back to the ground state. During the process, it emits the radiations. When it is jumping from the n equal to 2 to n equal to 1, then how much energy is related? This corresponding to the energy difference equal to hc by lambda. This corresponding to lambda maximum, means energy is different, energy is minimum. Energy difference is minimum between the adjacent levels, remember that point also. And therefore adjacent levels energy is minimum means lambda is maximum, frequency is minimum. And next to n equal to 2, we can take the relationship for this Lyman series, electron jumping from higher energy level to ground state. Ground state means n equal to 1, n1 is equals to 1, this is the ground state, and jumping from higher energy level. The beginning of the series is obtained when n equal to n2, n2 is equals to n1 plus 1, this immediate next level, that is corresponding to low energy maximum wavelength, this one, n2 equal to 2. Next, n2 equal to 3 onwards, you will get the expressions for the different wavelengths. But when n2 equal to infinity, it is called the end of the series. n2 equal to 2 is the beginning of the series, n2 equal to infinity is the end of the series. This is corresponding to n2 equal to infinity is corresponding to maximum energy minimum wavelength. Corresponding from infinity, that electrons are jumping, this corresponding to lambda minimum. Lambda minimum means maximum frequency, maximum energy corresponding to that. And this Lyman series is the UV region, ultraviolet region, which is not visible to the human eyes. This I mentioned here, n1 equal to 1, n2 equal to 2 is corresponding to lambda maximum, minimum energy. n1 equal to 1, n2 equal to infinity corresponding to minimum, lambda minimum and maximum energy relations. Next is Bohr series. Bohr series is a visible region, and that is corresponding to electron jumping from higher energy level to the first exit state. They are jumping from higher energy to first, they are not stable, again they jump back to the ground state. Electrons absorbing the energy from the ground state called the absorption spectra. Then it going back, again electrons to come back only. So absorption spectra leads to finally Lyman series. Bohr series observed the spectrum series, electron jumping from higher energy level to the first exit state. When the first exit state means n1 equal to 2, so first exit state is corresponding to n1 equal to 2 and n2 equal to 3, 4, 4 onwards. This is corresponding to the immediately first one. This is the beginning of the series corresponding to the minimum energy, maximum lambda, and end of the series corresponding to n2 equal to infinity. For all the series, n1 equal to 1, n2 equal to n1 plus 1 is beginning of the series. n1 equal to 1, n2 is infinity, is corresponding to the end of the series. Substitution of the values, you will get the corresponding wavelength values. We can calculate lambda 1 to lambda infinity. Next is Paschen series. For Paschen series, n1 equal to 3, n1 equal to 3, electron jumping from higher level to that n equal to 3, and n2 equal to 4, 5 onward. This is the beginning of the series, this is the end of the series. The Paschen series in the infrared region, which is not visible to the human beings, human eyes. Next is bracket series, name of scientist is, and n1 equal to 4, n2 is equals to 5, 6 and onward, that is also infrared region. Next is P fund series. Fund series is also in the invisible region, n1 equal to 5, n2 equal to 6, 7 onwards is also infrared region. In the visible spectra from VGR, violet to red. After red, what you get is microwaves. So in the red, after red, what you get is infrared. This is a VGR. After red, what you have is infrared. After that, what you have is microwaves. Then you have the radio waves. In the infrared region, the near infrared, 3 parts are there in this infrared region, is a very wide band spectrum. So near infrared is corresponding to the infrared first one, Paschen series, and then we have the middle infrared, and then we have the far infrared, so near, middle and far infrared regions correspond to these radiations. Hydrogen spectrum we are discussing here. This is related to the for hydrogen spectra. The spectral lines what we discussed is hydrogen spectra. Other than hydrogen spectra, if you want anything other element, if you require, no, wherever R is Z for calculation of Z lambda, wherever R is there, multiply with the Z square. This is for any atoms. This is for hydrogen atom only. We are discussing only hydrogen atom, Z equal to 1 relationship. Next, electrons jumping from higher energy to lower energy level. For example, jumping from here to here and here to here. This excited state will not be stable state, and electrons want to come back to the ground state. It may jump directly to the ground state, or it may jump into the intermediate levels. If the energy difference is equal to HF, then this energy equal to this energy difference plus this energy difference, means HF is equal to HF1 plus HF2. This is called the Ridge conjugation principle. The name of scientist is not important, of course. Then the relation only frequency and wavelength they will ask you. The frequency relation is nothing but equal to this total energy relation is frequency F is supposed to be equal to F1 plus F2. And C equal to F lambda, F equal to C by lambda. So F equal to C by lambda equal to C by lambda 1 plus C by lambda 2. They may ask with LCM also here. What you get is lambda is equals to lambda 1, lambda 2 by lambda 1 plus lambda 2 is a relation for the wavelengths for this series combination, spectral series when the electron jumping from higher energy level to in ground state with intermediate levels. And how many spectral lines can possible? This one wavelength, one frequency. This is a different wavelength. This is different wavelength. In this diagram, there are the 3 different wavelengths are possible. So spectra, if you pass this light coming out from this atom, when the electron is jumping, one atom may be jumping like this. In one atom, electron may jump to the ground state. In another atom, electron may jump from intermediate levels. It is unstable, again jump like this. So it's possible to have more than one wavelength coming out of the different atoms from the same excited materials. Then in that case, how many possible wavelengths you can get is 1, 2, 3. So you can take this n equal to 1. 2, 3. Then if substitute for n equal to 3, how many wavelengths, different wavelengths possible is you can get, that is called the number of spectral cities. This is to the ground state, jumping to the ground state. Intermediate states also formula I gave you, but that is not important for the KSET and NEET. Okay, only JMN that is required, just to go through the same notes for that purpose. This is for the ground state. So for the ground state, from higher energy level n to ground state, n to ground, the number of spectral series is equal to n into n minus 1 by 2. Next is this spectral differences, lines difference will be goes on decreasing. And if the electron is taken from ground state by absorbing the energy, electron taken from ground state to first exit state or second exit state, third exit state, it is called as a excitation, or atom said to be in exit state. Again electron jump back to the ground state. The energy required to take the electron from ground state to higher energy levels is called as the excitation energy. And corresponding voltage required, because energy we are taking the electron volts means the energy required is 2 electron volts. So what is the potential required is equals to 2 volts. Potential excitation energy corresponding value expressed in terms of electron volts means directly expressed in volts. Next is, that means the voltage required between for the discharge to be in between electrodes. That is the voltage required for the electron to accelerate and hit the atoms of the air and to exit the atoms. Next is, if you are taking the electron from one energy level to other energy level is called as the excitation energy, difference in energy you have to take. And if you are taking the electron from the in any energy level to the infinity, it is called as a ionization. The energy is called as the ionization energy, and corresponding potential is called the ionization potentials. In this excitation and ionization energies, we calculate from the basic formula of energy, that is E equal to energy level is nothing but equal to the nth orbit equal to minus 13.6 into Z square by n square y. If you take n equal to 1, that is the ground state. I am taking the hydrogen atom, Z is equals to 1 for hydrogen atom. So E1 is equals to ground state is minus 13.6 electron volts in electron volts. What is the voltage required is minus 13.6 volts. And n equal to 2 is the first excited state. First excited. N equal to 2, E2 is equals to 2 square is 4 minus 3.4 electron volts. N equal to 3, you will get a second excited state. E3 is equals to 3 is a 9, 13.6 by 9, you will get as 1.54 electron volts. I will check up these values. N equal to 4, that is the third excited state. E4 is equals to minus 0.84 or 85. You can calculate that value, 85 electron volts. Ground state energy equal to minus 13.6 volts. First exit state energy. This first exit state energy is nothing but equal to, this is minus 13.6 electron volts. Next is minus 3.4 electron volts. Next energy level is equals to minus 1.5 electron volts. Next is minus 0.5 electron volts, and so on. We can calculate any numbers. You don't have to remember all the numbers, you just have to remember up to 4. Directly you can save the time. Otherwise, you need to calculate by substituting n value in this expression. You can get the energies, and you must be able to find out it is in which exit state by knowing the values of the energies. If in the ground state, if you want to take it to the ground state to first exit state, means you are taking the excitation to the next level. That is the minimum energy required. The excitation to the next level is corresponding to the energy difference, that is E2 minus E1. That means N2 will be equal to 3.4, N1 is nothing but equal to 13 points. What is the energy difference becomes is excitation. Excitation N1 equal to 1 to N2 equal to 2 only. You are taking the energy difference is delta E. E is equals to minus 3.4 minus of minus 13.6, which is equals to minus 3.4, 10 it becomes equal to plus 10.2 electron volts. The energy required to take the electron from ground state to first exit state is nothing but equal to 10.2 electron volts. That is the excitation energy. Similarly, if you want to take the electron from first ground state to second exit state, then you have to take the difference is equals to, this is a minus 1.5, then minus 1.5 minus of minus 13.6. The difference is nothing but equal to corresponding excitation energy you will get. Next, if you want to take the ionization, and sorry, one more thing is potentials. Excitation potential is same electron volts expressed in volts. 10.2 electron volts means the excitation potential is nothing but equal to 10.2 volts. Next is ionization. Ionization energy is nothing but taking the electron from the ground any energy level to infinite separation. Infinite separation means no more attract to the nucleus. For that purpose, whatever energy is in that state, same energy you have to make it equal to 0. At the ground state, the energy is minus 13.6 electron volts. It is negative means the electron is bound to the nucleus. If energy is positive or 0, electron is no more bound to the nucleus, it will escape to the infinity. To make this energy 0, how much energy you have to add equal to plus 13.6 electron volts. This is also called as the binding energy. This is also called as a ionization energy. So ionization energy in the ground state is same energy whatever it was having total energy expressed in terms of positive values. So 13.6 means that you plus 13.6 is nothing but equal to ionization energy. And electron in the first exit state is there, n equal to 2 first exit state. What is the ionization energy? Ionization energy is nothing but equal to plus 3.4 electron volts. What is the potential? Ionization potential 3.4 volt only is the ionization potentials. Next we have to work out potentials. So problems we need to work out.